equivalence relation define a relation R on Z. We know Z is equal to what? Set of integers, and for any AB belongs to Z, for any or for all AB belongs to Z, A related to B if and only if A divides B, check whether R is reflexive, symmetric and transitive relation. Reflexive, symmetric and transitive relation. Also check whether it is an equivalence relation. Okay. So now for we have given for any AB belongs to Z, there exists a relation between A and B if and only if A divides B. Or symbolically it can be written as A divides B. This implies B is in multiple of A, that is B is equal to say m KB, Ka or m times A. Okay, here B is multiple of A. For example, 2 divides 6 because 6 can be written as 2 times 3. Okay, so similarly here AM, you can say that AM. Now we know that to check a reflexive relation, since A divides A for every A belongs to Z, and therefore A related to A for every A belongs to Z, and therefore R is an reflexive relation. In other words, we know that A is equal to A times 1. So you can say that A divides A, and therefore for every A belongs to Z, and therefore R is reflexive relation. Now to check whether it is a symmetric, now if suppose we know that if 2 related to 6, since 2 divides 6, okay, 2 divides 6, but 6 does not divide 2. In symbolic in words you can write 6 does not divides 2, and therefore 6 does not related to 2, and therefore this implies R is not symmetric. That is, if A divide B does not implies that okay, always B divide A. Okay, you cannot say this always, and therefore it is not a reflexive relation. Now for transitive, now if A divides B and B divides C, then B is a multiple of A, that is you can say that this is B is equal to A times K1, and C is equal to B times K2 for some K1, K2 belongs to integers. Then we want to show that A divides C, that is we want to show that here C is multiple of A. Now since from this equation we know that C is equal to BK2, and in this equation here if you put the value of B, then C is equal to A times K1, K2. So K1, K2 are integers, so you can say that C is equal to A times K3, where K3 is equal to K1, K2, and therefore this implies C is multiple of A C is in multiple of A, and therefore we can say that A divides C, and therefore there exists a relation between A and C, and this implies R is transitive relation. Transitive relation. Now R is reflexive. R is reflexive, not symmetric, but it is transitive. So since R is not symmetric relation, and therefore this implies R is not an equivalence relation, is not an equivalence relation. Hence relation. Okay, thank you.